Evening, ladies and gentlemen. So today we have been faced with one interesting question which reads, consider the functions f of x and g of x. Find the domain of f. So remember, if you are given a function which has a fraction in it, we need to understand to say that the domain of it doesn't need to satisfy the condition of where the denominator is equal to 0, because the function will be undefined. So we have f of x is equal to x over x squared minus x. So what we basically do is you will get the denominator and equate it to 0, so that you find the values which make this expression, the denominator, equal to 0, so that those numbers, they should not be part of the domain. So you know for sure that x squared minus 1 is equal to 0, so that we find the value of x. So we know for sure that for you to find the value of x, you square root both sides. And we know for sure that the square root of a number is both positive and negative. So now, having done this, we need to understand one general characteristic here. Remember, if I'm to put positive 1 and if I'm to put negative 1, the answer that I get down here is a 0. So which means the value of x should not be equal to the numbers negative 1 and 1. So which means that my domain will be all the way from negative infinity to negative 1 union. Remember, between negative 1 and 1, you have numbers, and from 1 itself all the way to positive infinity. So this is my domain. These are the numbers that will make this equation or function to be defined. Then from there, they're telling you to find the inverse of g. So remember, in tertiary education, we are told for sure that for you to find the inverse of a function, you need to determine if a function is basically 1 to 1. So let us determine if the function of g is basically 1 to 1. So we know for sure that g of x is equal to x squared plus 3. So for us to determine 1 to 1, we use two arbitrary letters a and b. So we say a squared plus 3. And we say g of b is equal to b squared plus 3. So having done this, we equate these to each other, and we have a squared plus 3 is equal to b squared plus 3. So where this and that will basically cancel, and you have a squared equal to b squared. So solving for a, we have the square root of that and the square root of this. And we know for sure that when solving for a, the two values you will get are positive and negative b. This tells you to say already that the function is not 1 to 1. So since the function is not 1 to 1, then g has no inverse because it is not 1 to 1. So there we have our last question, which is telling us, saying, is g an odd or even function? So for you now to prove whether g is an odd or even function, we always use the law of us having negative x. So if the result, when we place in negative x, we get the very same function as the original, then the function is basically even. But if you multiply the very same function which did not give you the even with a negative and gives you the original, then it is odd. So this is what I'm trying to say. So g of negative x, you know for sure that if I'm to plug in negative x plus 3, I still get the same result as the original function. Remember, the original function of g, you can even get it from here. So these two are the same. This tells you to say that this is what? Even. But is this odd? So if it wasn't even, we would have multiplied the very same function with a negative. So negative times that gives us negative x squared minus 3, where we know for sure that this is not anywhere closer to here. So this is not odd. So the way we will justify our answer is it is even because when we plugged in negative x into g of x, it still gave us the very same function that of g of x. So this is how basically you tackle such kind of questions. Your host, Golden Zulu.